So when we're looking for the greatest common factor, we need to first be able to identify how many terms something has. If it has a certain number of terms, you're going to use a different style of factoring, okay? So, any idea how many terms this one has, this polynomial has? How many terms that has? Any ideas? It has two terms. Two terms. The terms are separated by this plus symbol right here. This is the first term. This is the second term, okay? So number one has two terms, okay? This term and this term. How many terms does number two have?
Two.
They're only separated by one subtraction symbol, right? So this is a term and this is a term. So there's two terms. This one's a little funky looking, so we'll talk about number three in a second. How about number four? How many terms does number four have? That has four terms, right? Four terms separated by a plus sign, okay? So it can be helpful for you to understand, make sure you know what it means to have a number of terms, okay? So when we are factoring, no matter what problem you're doing, you're always going to make sure you factor out any greatest common factors, or GCFs, first, right? Any factors that are common to all the terms, okay? Now, sometimes, like number four, this is not going to have any greatest common factor, okay? And then we'll talk about what we do after that. But all of these 1, 2, and 3 have a common factor. So you're pretty good about this with numbers, okay? So let's talk about number one. We'll look at the two terms, and let's just start with the number part of the term. So if I look at the 18 and the 27, what's a common factor of 18 and 27? 3 and 9. Now we're looking for what? The greatest common factor. So which one are we going to pick? 9, right? So we're going to write that in the front. 9 is part of my GCF, my greatest common factor, but that's not it. These two terms also have some letters in their GCF, right? How many x's are in this first term, 18x cubed? How many x's are in that? 3, right? X cubed means x times x times x. So that's 3 x's multiplied together. How many x's are in the second term? 2. So how many do they have in common? 2, right? They have 2 in common. So that also is going to be part of my GCF, x squared. So my GCF for this problem, or my greatest common factor, is 9x squared, because both 18 and 27 are divisible by 9. That is the biggest number that they are divisible by, the biggest common factor. And 18x cubed and 27x squared are both divisible by x squared. Okay, so we found the GCF. Now we have to factor it out. Okay, so we're going to write in parentheses what we have left in these two terms when we factor out that greatest common factor. Now remember, we're undoing multiplication, right? So we're dividing. When you factor something out, you're dividing. So if I divide 18 by 9, what do I have left? 2. So I have a 2 left here in my first term. When I do x cubed divided by x squared, or when I take x squared out of x cubed, I have 3 x's here. I pulled 2 out. How many are left? 1. So 2x will be left in my first term. Then we have a plus sign separating our first and second terms. And I need to write down what I have left here when I factored out 9x squared. So what's 27 divided by 9? Because when you factor something out, you're dividing. What's 27 divided by 9? 3. I had 2 x's in this term to start with, and I pulled 2 out. So how many do I have left? 0. None, right? So there's not going to be any x's left. Now, guess what? Factoring is the best of all, because you could always check your answer and see if you're right. Because remember, we're undoing the multiplication. If I gave you this as an answer, or as a problem, sorry, not as an answer. This is our answer, right? If I gave you this as a problem, do you know how to multiply those together? Do you know how to multiply those together?
Yeah.
You would do 9x squared times 2x, and you would get 18x cubed. You would do 9x squared times 3, and you would get 27x squared, right? So you could always check your answer and multiply it out and make sure you got where you started, okay? All right, let's start with number 2. So I want you to write down on this line right here what you think the GCF is, because the GCF always goes in front. So write down what you think the greatest common factor is. This one also has how many terms? 2. So you need to find the biggest common factor between those two terms. So look at the numbers first, do the letters, and write that down on this line right in front of your parentheses. so start with your numbers first. What do 12 and 20, what are their common factors? 4 and 2, but which one do we want to pick? 4, because we want the greatest common factor, so part of our GCF will be 4, but that's not it, because they also have some common factors with the letters. 12x squared has 2 x's. 20x cubed has how many x's? 3. So how many do they have in common? 2. So that needs to be in your GCF. Your GCF is this number in the front. The first term has x squared, so that means there's 2 x's. This one has x cubed, so they have 2 in common. So that's what we're factoring out. How many y's are in this first term?
2.
How many y's are in this one?
1.
Just 1. Remember, that's a 1 power. So how many do they have in common? 1. So that also needs to go in my GCF. So my GCF, or my greatest common factor here, is 4x squared y. That is what both terms have in common. Their biggest common factor. Then I need to write what I have left in each term when I factor that out, or when I divide that out. So what's 12 divided by 4? 3. So in the first term, I have a 3 left inside the parentheses. 12x squared had 2 x's to start with, and how many x's did I pull out? 2. So how many x's are left in this term? None. It had 2 y's to start with. How many y's did I pull out? 1. So how many are left? 1. So 3 y's left in my first term. There are no x's left. There's a subtraction sign separating my 2 terms. Now I need to factor 4x squared y out of 20x cubed y. So write down what you think is left when you pull this GCF out of 20x cubed y. Write down what you think there should be left. All right, you should have 5x here, because 20 divided by 4, when we factor something out, we're dividing. 20 divided by 4 is 5. There was 3 x's to start. We pulled out 2. And there was 1 y to start. We pulled out 1. So there was 1 x left and no y's. That is factored now because you have pulled out the greatest common factor. Any questions about 1 and 2? GCF. I think this tends to be, we have to do the GCF with a lot of things, so we need to make sure we understand this pretty well. All right, number 3 looks a little funny, but we're doing this one on purpose because we're going to do stuff like this in the future. How many terms do you think this one has?
2.
It's tempting to say 4 terms because I see a plus, I see a minus, and a minus, okay? But there is actually only 2 terms, okay? There's this term and this term. Because all of these are being multiplied together. 2 times x minus 7. That's all one term because it's all being multiplied together. This has 2 factors, 3 and x minus 7. Okay, so those are all being multiplied together. So here there's 2 terms. Now, if I distributed that out and this out, then I would have 4 terms, right? So if you are thinking 4, if you distributed that and that, then you would have 4 terms. Some of it may combine down to less than 4, but the way that it is right now, there is only this term and this term. So when we're looking for our common factor here, we need to compare 2, x, and x minus 7. Those are the factors here, because factors are things multiplied together. So 2 is a factor here, x is a factor here, and x minus 7 is its own factor, because it's being multiplied by that. Here we have 3, and we have x minus 7. What do those have in common? X minus 7. It's pretty obvious, right? They both have an x minus 7 factor. So that is our factor that we're going to pull out. Is x minus 7. And then we're going to write in parentheses what we have left in those 2 terms when we pull out x minus 7. So in this first term, what do I have left if I took out the x minus 7? 2x. Then there's a plus sign separating our 2 terms. And what do I have in this second term when I take out the x minus 7? Yep, there's a 3 left. So now you have factored this into x minus 7 times 2x plus 3. So that one looks a little funky, but it's because it's going to help you with what we're doing next. Any questions about that one? Okay, so now we're going to move to factoring by grouping. Factoring by grouping, you can use whenever there's an even number of terms, but usually we're going to use this when you see 4 terms. So when you see 4 terms, you're always going to try factor by grouping. Now, no matter what kind of factoring you should do, you should always factor out a GCF first. If there is a greatest common factor, that should be what you do first, okay? But let's look at all 4 terms here in number 4. Is there a common number that is common to all 4 terms? Is there a factor as number-wise that's common to all 4 terms?
No.
These two have a 2, but is this one divisible by 2? No. These two have a 3, but is this one divisible by 3? And then over here we just have a 1, so it's not going to have anything in common with all of them, right? Do all of them have at least one x in them? All 4 terms? No. Does this last term have an x in it? No. So this doesn't have any greatest common factor, but if it did, you would want to pull that out first, just like we did with our other problems, okay? So then, once we have pulled out a greatest common factor, that should be always your first thing you do, okay? Now, when we're factoring by grouping, we're going to do something very similar to what we just did, but we're going to break the problem into 2 parts. Since there are no more greatest common factors, we're going to put a dotted line here, right down the middle, and split it up into 2 sections. And you're going to look at this side and find a greatest common factor. Do those 2 terms have a greatest common factor?
Yes.
Yeah, what do those 2 terms have as the greatest common factor?
3.
Why 3? These 2 or these 2?
Oh, the.
Are you over here?
Oh,
Yeah, I'm
sorry,
covering that
sorry.
one. Sorry, you're fine, you're fine. You're just ahead of me. We'll do that next.
Okay.
Yeah, these 2 over here. Sorry. These 2 over here, do these have a common factor?
X squared.
Yeah, x squared is their common factor, right? They don't have a number in common, but they both have at least an x squared, right? Yeah. Yeah, take the whole pass. Okay, so we can write that down in front. The greatest common factor is x squared. And then in parentheses, you're going to write down what you have left you're just looking at that side, right? So you're factoring out the greatest common factor for just that side. So write down what you have left in parentheses when you pull out an x squared out of those 2 terms. What would we have left in parentheses there? So when we factor out x squared out of x cubed, how many x's are left? X cubed, you're going to take x squared out. How many are left? Just 1 x, right? So there will be an x. Then those 2 terms are separated by a plus sign. And what do you have left in this term when you pulled out an x squared? 4. So you have an x plus 4 left when you pull out an x squared out of these 2 terms, right? That's just what we practiced earlier, greatest common factor. Now, do the other side. Find the greatest common factor and write that, factor it out, and then write what's left in parentheses. Do that part on your own. Yes. So do the right-hand side on your own. Look for your greatest common factor, write that in the front, and then write what you have left in parentheses. What's my greatest common factor of these 2 terms? 3. 12 and 3 are both divisible by 3, so that's my greatest common factor. When I take a 3 out of this term, what am I left with? An x. When I divide 12 by 3, remember factoring out, you're dividing because you're undoing multiplication. When I divide 12 by 3, what do I have left? 4, and they're separated by a plus sign. Now, whenever you do this factoring by grouping, these 2 that are in the parentheses should be the same. Do you see how x plus 4 and x plus 4 are the same? If you do not get those to be the same, that means you did something wrong. So stop there and check yourself. So in this case, these are both the same. They should be. Now, the only other thing we need to do is we're going to put this 3. Is this a positive 3 or a negative 3?
Positive.
It's positive. So we need to leave a plus sign there in the front of it. Okay? So we're basically bringing down this plus that was in front of the 3. Okay? Now we're back to a problem where we have 2 terms separated by a plus sign. And what do these 2 terms have in common? What do those 2 terms have in common? I just talked about it a second ago. What do they have in common? Pretty obvious, right? They both have x plus 4. So we need to pull out that x plus 4. And then we need to write what we have left in parentheses when we pull out an x plus 4. So you're going to look at this first term on the left side, and then the right side, and write down what you have left in parentheses. So when I take x plus 4 out of the left side, what's left on the left? Just x squared. Then we have a plus in the middle, separating them. And what's left on the right side when I take out x plus 4? Just a 3. So plus 3. And now you have factored that 4-term polynomial. And guess what? Factoring is awesome because you could always check your answer and see if you got it right. You know how to multiply these together, right? You just distribute or FOIL, and if you do it, you should end up right back here where you started. Okay, if you wanted to check your answer. All right, we're going to kind of do 5 on your own kind of together because there's one common mistake that a lot of people make with number 5. So we start by putting a dotted line down the middle. Now look for your GCF on the left and your GCF on the right and write what you have left in parentheses. I want you to start this part on your own. GCF on the left, GCF on the right. This is probably the type of factoring you've practiced the least in Algebra 2. So it might be the kind that you need the most help on. Some of you might remember it really well. Pause right here. This looks pretty good. I'm going to help you with this part. Okay, on the left side, what's my GCF, my greatest common factor? On the left, what do they have in common? X squared. When I pull that out, I should be left with an x plus 5, yes? Pull out an x squared out of this, you're left with an x. Pull an x squared out of this, you're left with a 5, right? What did you guys pull out as your GCF over here?
-2.
So some people, did you do positive 2? Okay, some people did positive 2, okay? Yes, 2 is the common factor. When there's a negative in front of that number right there, I want you to pull it out with your greatest common factor, okay? So we're going to pull out a -2. And if you did not pull out a -2, here's your problem. You ended up with a -5 in the parentheses, right? And we need this to be a +5. It has to match, right? It has to match. So right now, when I pull out a -2, what's going to be left in this first term? X. And then when I pull out a -2 out of -10, remember you're dividing. So it will be -10 divided by -2. What will I have left now? Positive, right? A negative divided by a negative will make this +5. You're doing -10 divided by -2 because that's what you pulled out. And that will leave you with that +5 we needed, right? Because this has to match. If it doesn't match, we did something wrong. Does that make sense, what we did? So if there's a negative in front of this number right here, make sure to pull it out with your greatest common factor. All right, so now what do these 2 terms have in common? X plus 5, so we're going to pull that out. That's going to be one of our factors. And then we look at those 2 terms and we write down what's left when we pull out x plus 5. In this first term, what's left when I pull out x plus 5? X squared. And in the second term, what's left when I pull out x plus 5? -2. And so now we're done factoring. Again, you can check it, you can multiply it out, and you should end up right back where you started. Any questions about that one? Factoring by grouping. Okay, this is probably what you will remember the most from Algebra 2. Factoring trinomials. So how many terms do all of these have? How many terms do all of these have? Three, okay? And with all of these problems, these are all quadratic, right? With this form, ax squared plus bx plus c, okay? But with all of these, what number is in front of the x squared? With all of those, what number is in front of the x squared? 1. So here with all of these problems, a is equal to 1. These are the easy ones, okay? Tomorrow, we will tackle the ones where a is a number, when you have a number in front of those. Those are the hardest kind of factoring, okay? And then b is the number in front of the middle term, and c is your last number. When you're looking to solve these, this is where, if you like the x method, anyone use the x method? Okay, you can use the x method for factoring these. Basically what we're doing is we're looking for two numbers that multiply together to get c, and add together to get b, the middle term. So we're looking for two numbers that multiply together to get the last number and add together to get the middle number. So for number 6, we're going to look for two numbers that multiply together to get what? Yeah, what's c here? 8. So we're looking for two numbers that multiply together to get 8, but also add together to get what? 6. So two numbers that multiply together to get 8 and add together to get 6. Give me two numbers that multiply together to get 8. 2 and 4. What else? 1 and 8, right? That's another possibility. Now, do 1 and 8 add together to get 6? No. But do 2 and 4 add together to get 6?
Yes.
Yes, right? So here, those are going to be your two numbers. 2 and 4, because they multiply together to get 8 and add together to get 6. And that tells you what your factors are going to look like. So with all of these trinomials where we have 3 terms and the number in front is 1, they're really easy to factor because we already know what these two terms have to be right here, because those have to multiply together to get x squared. What times what gives me x squared? X times x, right? So these two have to be x to multiply together to get x squared. So all of these, whenever that a is 1, will always start with x and x. And then guess what? You just found the other two numbers, right? It's going to be a plus 2 and a plus 4, because those are the two numbers that multiply together to get 8 and add together to get 6. And that is all you have to do. You factored that. If you undid it and you multiplied this together, you would do x times x to get x squared. You would do 2 times x and x times 4. That's why we wanted them to add together to get 6. And then you would do 2 times 4 to get 8. All right, let's do one more together. If you like the x method, you're welcome to use the x method. Okay, so for number 7, we're looking for two numbers that multiply together to get negative 18 and add together to get 3. What numbers multiply together to get 18? 6 and 3. What else? 9 and 2. What else? 18 and 1. Now, we need them to multiply together to get negative 18. So what does that mean if two numbers have to multiply together to get a negative? One of them is going to be negative, right? And then we need them to add together to get 3, right? If I make this 2 a negative, will these add together to get 3? No. And if I make the 9 a negative, will these add together to get 3? No. So which combo do you think we're going to be looking at?
6 and 3.
6 and 3. If I put the negative with the 6, will that add together to get positive 3? No, right? That's going to be negative 3. So what's the negative going to have to go to? It's going to have to go with the 3. So put the negative with the 3, and now those two will multiply together to get negative 18 and add together to get positive 3, right? So that tells you when you look at your factors, You know it's going to have to be x and x here because x times x is x squared. And we know the other numbers now are going to be positive 6 and negative 3. And that is your factor. Factoring. If you wanted to check your answer, you could multiply it out and make sure you get back to where you started. Okay? This is probably what you remember the most about factoring in Algebra 2 is this method. Hopefully it rings a bell. I want you to try 8, 9, and 10 on your own. If you want to use the X method, you're welcome to. Yes. If you need help still, let me know. Hopefully some of you are bored since you factored your minds out in Algebra 2. That's okay. You're welcome to keep trying. If you know what we're doing, you're welcome to keep going on the back. If you already feel good about your factoring, do some practice on the back. Okay, then don't get on your phone.
There's no.
Right, there's no greatest common factor. So now when you have the 3 numbers, that's when you're going to be doing what we just did here. When you have 3 numbers and no greatest common factor, you're going to look for 2 numbers that multiply together to get what? Multiply together to get 9, add together to get a negative 20. So start with the numbers that multiply together first. There's lots of numbers that will add together to get 9. So it's better to start with that with your little list. I like that you start the list here. You can start with numbers that multiply together to get 9. So yeah, because I did 1 and 20, but that big of a number is usually not going to be a combo. So you can throw it down if you want, but a lot of times that's kind of what I'm doing. Does that make sense? Now, we need 2 numbers to multiply together to get a positive. We're going to add together to get negative. So that means both numbers are negative, right? This is 1 to multiply together to get a positive. So then, yeah, there you go. You can use your calculators with these to help you check the combos if you need to. I know some of you are really good with the mental math without them. That's great, but if not, use your calculator. Okay. So what are we looking for? We're looking for 2 numbers that multiply together to get what? And add together to get what? 9. So write down a list of numbers that multiply together to get 20. What are some numbers that multiply together to get 20? Okay, I would, yep. And then what else? What else? 1 and 20 is technically not on this slow, but sometimes might come. Okay. Now, those also have to add together to get what? Negative 9 specifically, right? So, how are 2 numbers going to multiply together to get a positive, but add together to get a negative? So I think you found your combo, right? And it'll be x minus that, x minus 5, x minus 4. All right, let's talk about each of these real quickly here. So for number 8, we need two numbers that multiply together to get 20 and add together to get -9. Now, how in the world, well, first let's multiply two numbers together to get 20. So let's see. Numbers that multiply together to get 20 are 4 and 5, 2 and 10, and 1 and 20. Those are all your combos, okay? Now, how in the world are two numbers going to multiply together to get 20, but add together to get a negative? How are two numbers going to multiply together to get a positive and add together to get a negative? Yeah, they both have to be negative, right? So if you make both of these negative, you're going to get -12, right? That's not going to help us. These two negative, -21. But if you make -4 and 5 negative, you'll get -9. So this will be x minus 9, or x minus 5, x minus 4. Again, you can multiply it out to check your answer. For number 9, we're looking for two numbers that multiply together to get -72 and add together to get -6. So when I think of numbers that multiply together to get 72, I think of, 9 and 8 or 8 and 7? Which one makes 72? 6 and 12. What else? Is it 9 and 8? 9 and 8. 9 and 8. That's what it is. 9 and 8 makes 72. There's a few different combos out there. Those are some of the most common ones. If I have a -72, two numbers multiplying together to get negative, what does that tell me about one of my numbers? One's going to have to be negative. We're multiplying two numbers together and it's a negative. One's going to have to be negative. If I make one of these a negative, that's not going to help me get -6. So 9 and 8 are out. I'll get 1 or -1. If I make these 6 negative, then I'll have +6, but I want -6. So the 12 has to be negative. So this will be x minus 12, x plus 6. All right, and for number 10, we need two numbers that multiply together to get 5 and add together to get 7. What two numbers multiply together to get 5? Don't say 2 and 3. 2 and 3 multiply together to get 6. Yeah, there's only two numbers that multiply together to get 5. What are they? 1 and 5. Can you add 1 and 5 together to get 7? No, so is there an answer to this one? Is there a combo of numbers that multiply together to get 5 and add together to get 7? No, and that's possible. It's possible for something not to be able to be factored, okay? When we can't factor something, we call it prime, okay? So this would be prime. Because the only two numbers that multiply together to get 5 are 1 and 5, and there's no way for those to add together to get 7, okay? So this one would be prime. Any questions about that factoring? So this is probably what you remember the most. Grouping is probably what you're going to need the most practice with, okay? But if you need practice with this stuff, this is the only day we're going to practice this stuff. So make sure you keep up with the homework, okay? Some of you are going to remember it really well, and that's great. But other people probably will need some practice. So there's practice at the bottom of this page on the back that you can use as well as here. Last two types of factoring are pretty easy, okay? These two, all three of these problems have how many terms in them? How many terms are in all three of these? There's 2 terms, and they all have subtraction, okay? And on top of that, not only do they have subtraction, but they have special numbers in them. 16, 9, and 25. Do you recognize those numbers? Are those special for some reason? 16, 9, and 25? What are those numbers? Yeah, they're perfect squares, right? So when you see a difference of 2 squares, or you could call it dots, a difference of 2 squares, it's really, really easy to factor. Okay, when you see a difference of two squares or dots, so here, this is a difference. Is 16 a perfect square? Is x squared a perfect square? I mean, it's squared, right? So it's definitely a perfect square. Here, this is a difference. Is 9 a perfect square? Is x squared a perfect square? And is 25 a perfect square? Yeah, so these are all difference of squares questions, and they're really easy to factor, okay? All you need to know is what made that a square. So what times itself gives you that. So for example here, we know these two have to be what? Because what gives me x squared? What times what gives me x squared? X and x, so these two have to be x. And what times itself gives me 16? 4, right? So whenever you're doing the difference of perfect squares, you're always going to use that number that makes it a perfect square, right? 4 times 4 is what gives me 16. So these are both going to be 4. One's going to be plus and one's going to be minus. Always when you have a difference of squares, it's really easy to factor, okay? It's always going to be your perfect square, the square roots of those numbers in those parts. One will be positive, one will be negative. Now, you could also think about it the same way we just did the ones on the other page. You just don't have a middle term, right? So your b in the middle is 0. So you're looking for two numbers that multiply together to get negative 16 and add together to get 0. Well, that would be 4 and negative 4, right? So you can think about it that way if you want. So for number 12, this is also a difference of squares. What are these going to have to be? Since 9x squared is a perfect square, what are the front two going to have to be? What, when you multiply by itself, do you get 9x squared? 3x, right? So that's going to be 3x and 3x. One's going to be positive, one's going to be negative. And then what number multiplied by itself gives you 5? 25, sorry. 5. So one's going to be plus 5 and one's going to be minus 5. This one's a little weird because 32 and 8 are not perfect squares. But remember, we should technically always look for greatest common factor to factor out first. Does this have a greatest, do these two terms have a greatest common factor? I think even bigger than 4. 8. Isn't 32 divisible by 8?
Yes.
Yeah, right? So we can pull out an 8 first. 32 divided by 8 is 4. So then we'll be left with 4x squared minus y squared. So here I just pulled out a greatest common factor first. Remember, sometimes you might need to do that. If there is a greatest common factor, you should factor it out first. Now, is what's inside a difference of two squares now? Is 4 a perfect square? Is x squared a perfect square? And is y squared a perfect square? So now this is a difference of two squares. So I can take what's in the parentheses and put it into its own two sets of the parentheses. This will have to be 2x and 2x because that's what multiplies by itself to be 4. One will be positive, one will be negative. And then what will these have to be so that we get y squared? Plus y and minus y. And then you just need to stick your 8 back in the front there that we factored out at the beginning. So difference of squares is really, really easy because it's just the two numbers that make that a perfect square. And you just always have a plus and a minus. But remember, is it a sum of two squares? Does it say it's a sum of two squares? No, it says a difference of two squares. So if any of these were a plus sign in the middle, you wouldn't be able to do this. Okay, this is only for a difference of two squares. Any questions on 11, 12, and 13? Okay, these last ones you don't see very often, okay? But you will see them sometimes, and I will always give you the formulas, okay? So these are really just needing to understand how formulas work, okay? And these are sums and difference of two cubes now, okay? We don't deal with cubes very often, so I've put your list of cubes over here, okay? So 8 is a perfect cube because 2 times 2 times 2 is 8, right? 2 cubed is 8. 27 is a perfect cube because 3 times 3 times 3 is 27. So these are your perfect cubes. So over here, is this a cube? See how it's x cubed, right? It's a perfect cube. How about 216? Is that on our list of perfect cubes? Yeah, so this would be a sum of cubes, right? Here, Is 8 a cube in our list? Yeah. X is cubed, and 1 is technically a perfect cube, right? Because 1 times 1 times 1 is 1 cubed, right? So this is a difference of cubes, okay? And then this one is also a sum of cubes because technically that one is a cube as well, okay? So when you do this, you just need to figure out what A and B are and then plug them into the formula. So for each one, you need to figure out what A and B are and plug them into the formula. So if you look at our formula here for both the sum and the difference, it says A cubed plus B cubed. So A and B are the numbers that are being cubed. So like for instance here, 216, what is being cubed that gives me 216? 6. So 6, see how 6 cubed is 216, right? So B is going to be what? 6. What is being cubed here? That one's pretty obvious. X, right? So A is X. And which one of these formulas should we be using? The sum or the difference? The sum. So then you're just going to go read that formula and write down what it says. It says start with A plus B. So X plus 6. Then you have A squared. So X squared. Minus A times B, so 6x, plus B squared, so plus 36. So if you can figure out what A and B is, you just plug it into the formula. Like I said, I'll always give you this formula. I want you to write down what you think A and B here are for 15 and 16. Go ahead and try both. So for number 15, what's being cubed here? What? Yeah, the x is being cubed. The 8 is not being cubed. What was cubed that gave me 8? 2, right? So here 2 is being cubed and x is being cubed. So A is 2x. And for this part, what's being cubed? Just 1. Just 1. The minus is its own part. Just the 1 is being cubed. Okay? Because the minus is part of the formula. So then we'll go down and which one of these formulas will we use? The sum or the difference? The difference. So now we're going to do A minus B. A squared, when you square 2x, you have to square both parts. So that will be 4x squared. Minus A times B, plus A times B. So 2x plus B squared, 1 squared is 1. Any questions about how we use the formulas? Again, I'll always give you those formulas. These don't come up very often. And if you want to try the last one, you're welcome to. A is actually x squared, and B is 5, if you want to try that one. So there is a homework worksheet for this. Like I said, we are going to do a few more days of practice factoring before we have a quiz, but we're not going to practice this kind tomorrow. We're going to do the more difficult kind. So if you definitely need practice with factoring, definitely make sure you pick up tonight's homework if you need practice with this type of factoring from today, okay? I also made a few more extra copies of Friday's homework. Remember, that was on the back of your notes on Friday. But that is what our quiz tomorrow is over. So if you want to come, Friday's homework is Intro to Polynomials. I printed off a couple extra. That was on the back of the notes, so you should have it. But if you want to pick up an extra copy of Friday's homework, and then today is factoring. So they're both up here on the table if you would like to pick one of those up before you go. I'll put the answer for this one up here. Yeah, factoring is going to be later in the week. We're going to do it all together.